Okay, things that depend on things. So energy depends on sleep, coffee depends on water, and so on. Here's another example. I'm doing video for people who are absent. Ah. Quantify.
Go with trees and dirt.
Trees and dirt?
Okay, and then you're going to come up with some kind of numbers
Okay.
that have some kind of meaning with that. It's all right.
Minus expenses.
So don't create an equation right now, but just say if there's this much profit, there's this much income.
Okay.
Sure, miles driven compared to gallons used.
Okay, so the number of miles driven depends on how many gallons you use.
I guess we probably should
Is that
have
what,
switched that gallons used.
or the number of gallons you use depends on the number of miles driven. Okay, could it go either way?
Yeah.
Okay. All right. Is this a function? The position of the sun in the sky depends on the time of day.
Yes.
Okay, so let's make a table. So our input is what? Okay, this position of the sun in the sky depends on the time of day. So the input is the time of day, and the position is output. The output is the position. Okay, give me some examples. 8 a.m.
Sunrise.
Okay, so where's the position of the sun at 8 a.m.?
Like sunrise, just peeking over the horizon.
Okay, it's right above the mountains. 30 degrees off the horizon.
Sure.
Numbers, right?
Yeah.
Okay, where is it at? I'm going to go backwards. Where is it at 5 a.m.?
Below, so like -5.
Negative 5%. Okay. Where is it at 12? 90 degrees. Where is it at 8 p.m.?
175.
175. So what time of year is this the case?
Summer.
Summer.
In the summer?
It's winter.
Like right now?
Yeah.
So what about at 8 a.m. in the, no, let's go with 5 a.m. in the summer. In July, what's the position?
5 a.m. in the summer, so that's around like 30.
At 5 a.m. in the summer, it's at about 30.
Okay, now what if we live in Alaska?
What if we live in Alaska?
Yeah.
Is it a function?
No.
Actually, it could be.
Just depends on your parameters, right?
Perfect word. What are your parameters? That's the same word I was going to use. What are your parameters? So maybe we would say the position of the sun in mid-September in the sky depends on, or the position of the sun in the sky depends on the time of the day in mid-September. That's a function.
And your location on.
And you might even just give it a date and a location. You could be exact about it, or you could say, where is the position of the sun right now around the whole world? At 5 a.m. here, it's all over the place, right? Okay, so parameters matter. Point being is some functions, it depends on how you define it, okay? How about the height of a child depends on the age? Function or not a function?
Yeah.
Depends on the parameters too.
Okay, what are the parameters? A specific child, like on their birthday. So the height of my daughter depends on her, no, yeah. The height of my daughter depends on her age on the day of her birthday. Okay? So she could be different heights during her whole 12th year, but on her birthday, she's only gonna be a certain height that day. Okay? So now, again, you may be thinking, how does this work on a test? And honestly, since we used to do paper pencil tests, and I actually had a student who gave an answer that I would have thought was wrong, but he also gave his parameters, and I was like, you're right. And so, but on the computer, they're not. Okay, one more. The number of followers on your Instagram each day. Is that a function? What would be the input? What would be the output?
0 constant.
Constantly 0. Okay, so what's the input? Let's define it.
Input is posts. How about that?
Well, the number of followers on your Instagram each day. What's the input? What day? And what's the output?
Number of followers.
Followers. You'll notice that we started off saying with the output on the left and the input on the right, but in a function and in math and all that, we always put the input on the left and the output on the right, okay? So this is basically X and Y, okay? We'll get to that. Okay, so on Tuesday, today, what's today's date? 26th of September. How many followers are on your account?
Mine?
Uh-huh.
Like
Oh.
75.
Who doesn't have an Instagram? Okay, 0. How many followers are gonna be on that account tomorrow?
60.
0. 0. Somebody who doesn't have an Instagram. How many the next day? 0. Okay, is this a function?
Yes.
Because?
It's day times 0.
And each input has one output.
Each input is matched to one output, okay? Today, there are 0 followers and only 0 followers. Tomorrow, there will be 0 followers and only 0 followers, okay? All right, we covered that idea now. But,
Sometimes where it's like the same input.
okay, remember how I say mathematicians are inherently lazy? So we don't want to be using all of these words. So instead of all of these words, we use notation. I am doing too much talking, but it's going to be it. So we use notation like this. So if we said the amount of tuition, yeah, it's not dry.
AMT, that's where you get money.
AMT, amount. I'm all into abbreviations. The amount of tuition, here's another abbreviation for you, is a function, FCN, of, what did we say that was? Credits, number of credit hours. Which is also CH. So the amount of tuition is a function of credit hours. We can represent that as T, the amount of tuition, is a function of credit hours. This is notation. We might have to start our next class with this other exercise. So this F is a label, it's not multiplication.
It's not
Okay.
F times C. It's C is a function.
Yeah, well, T is a function of C. Yeah, this means T is a function of C. And which is the input? Credit hours. So the input is the thing that's inside the function notation, and the output is what it's equal to. Okay, input output. So, at your tables, I know you're mixed groups right now, but look at your examples that you were doing and write an equation like this for that example. Okay, somebody tell me your example. Forgot who was working with Ethan. Ethan, what'd you guys have? What's your equation?
So ours is G equals the function of M.
G.
So gallons used equals the function of miles driven.
Okay, so gallons are a function of miles. Okay? One more.
What if we did the opposite? Miles are.
Well, you had your input was
The gallons.
gallons. Okay, this is good to look at. So, what is it then? M?
And, yeah,
Equals a function of G.
Okay. So they wrote their input was gallons, gave us a certain number of miles. Yours is that we're gonna use this many gallons
Let's drag that.
if we drive this many miles.
There's a bijection.
Say that again?
That means there's a bijection
Bijection?
between the sets.
I don't know that word.
In a computer structures class, and we
Ah.
just ran over functions, but in the context of like sets and stuff.
In sets, okay. Sets is like this huge genre of theory. Okay, so let's look at some equations, and you decide whether or not they're functions. Okay? If I let a value be, if I plug in a value for x, will the answer always be one value? If I let x be 2, is the answer always 8? I mean, 10 minus 2. Yes. That's a function. If I plug a 2 into x squared, is it always going to give me 4? Okay, every x plugged in is always going to give me one output. What if I switch that? Is if x is 9, is y always going to be 3? No?
Yeah.
Oh, y could also be negative 3.
yeah.
So x could be matched to positive 3, and x could be matched, or 3 could, how am I saying that? Yeah, negative 3. So the input could be matched to 2 different outputs, not a function. How about y cubed, or y equals x cubed?
Yes.
Every value I plug in for x, I'm going to get a unique output, right? How about this radical? This is a radical equation. For whatever value I plug in, do I always get the same, do I always get one output?
No.
Why?
Because in order to get rid of the radical, you have to square both sides, so it'd be 2x minus 6 equals y squared, and then if you solve for that, you'd get basically, not the equivalent, but like similar to number 3.
Okay, did that make sense? So if you tried to get x by itself, you're going to end up with a y squared in it, which comes back to this issue here.
Of
Okay.
the positive and negative answer.
Yeah, that's one way of looking at it. Sometimes we put, well, we don't even talk about that. Okay, so that's just another way of looking at these.